Hello, this is another question from a student. This is coming from section 4.4, the application. It's problem number 14, and it refers to a parabolic arch, and it's 120 feet wide at its base. It's 25 feet tall at the center. And what they wanted to know is how high is this arch at 10 feet, 20 feet, and 40 feet from the center. So how high is the arch at that point? And so what they said in the problem is basically you were about to create an equation in a rectangular coordinate system. So what I'm going to do is I'm going to draw a little picture of this arch. Okay, one point is going to be at the origin, and I'll try to draw the best arch I can. And it's in the shape of a parabola, so it looks like that. Now, it's 120 feet wide at the base, so that point right there will be 120. So if you kind of put this stuff together, you can figure out what the high point is on this rectangular coordinate system. The vertex is going to be right in the middle, okay, which is 60 feet from either end, and it's 25 feet tall. So this point right here will be 60, 25. So that's where the vertex is going to be. Now, if you create the general quadratic functions, a times x minus h squared plus k, actually that's the standard form, not the general form, and you plug the vertex in, so that would be, well, let's just call it alpha of x instead of y. Alpha of x equals a times x minus 60 squared plus 25. Now, I do know that this parabola does open down. I don't know what the a is, though. That's my problem. I'm going to have to figure out what that is. But you're like, well, I need another point. And some of the other applications we had, there was a problem. There's a point here somewhere that you just plugged in for the x and the y coordinate. So you don't have one of these up here. So you're going to have to use either the origin or this point right here. And I think the origin is probably easier. So I'm going to use the point 0, 0. So if you use the point 0, 0, you get 0 for the y equals a times x minus 60 squared plus 25. And if you start solving for a basically turns out to be negative 25 over 3600. Okay, that's what a is. You move the 25 over, and then negative 60 squared is 3600, and divide by the 3600. So that's what a is. Now, that actually reduces down to negative 1 over 144. So you take 25 divided by 25, that's 1. 3600 divided by 25 is 144. So the function is f of x equals negative 1 over 144 times x minus 60 squared plus 25. So that's your working function right there. So that would be the function that this one's associated with. So now I can answer their questions. How high is it? 10 feet from the center, 20 feet from the center, and 40 feet from the center. So you can either find it on this side or this side. And the numbers on this side are smaller. So if you go 10 feet from the center, that point is not going to be 10. It actually is 50 because it's going to go 10 this way. So this point right here is going to be 50, comma, something. You don't know what the something is. That's what you're trying to find. And then 20 feet this way, okay, well, that'd be 20 feet from 60, so that'd be 40 and something. And then the next question is, well, 40 feet from the center, so that would be 40 this way. So it's going to be 20, comma, something. So what you're trying to do is just evaluate it at those three numbers. You got to do L of 20, and that gives you the last answer they're looking for. L of 40, the middle question, and then L of 50. And L of 50 represents this, which will be higher than F of 40, of course, because it's higher up on the graph. So basically, you're looking for these heights right here. That's the questions you're being asked right there. It's those heights. So anyway, so when you answer these questions, F of 20, F of 40, and F of 50, you've answered their question. So, but again, it all hinges on writing the function in a standard form. Try and draw a pretty accurate picture of what they're talking about. That's the biggie. It's a parabola shape, okay, and it's 120 feet at the base on a rectangular coordinate system. So you kind of have to draw the visual accurately, or you're stuck in the mud right off the bat. So, and that's probably the biggest challenge students have on these types of applications is actually visualizing from words into a correct picture. Get past that, the rest of it's just algebra, and usually students on the algebra part of it have got that knocked down by now. But it's the visual. Try and transfer it from the words into the visual. And that's the challenge here. So, but anyway, this is number 14, section 4.4. And that's it.